Alright, this video is to introduce and demonstrate a new tool that we've been working on for some time now. We're calling it the audio multimeter, or the AMM-1. This is a multimeter just like a like a DMM, except for this one has a little audio twist to it in the way that it can measure multiple things at the same time, and it also measures clipping. You see it's got the voltage probes here. They come out of the front. These will be removable banana plugs, like a regular, like a fluke meter or something like that. And this hole here is the current sensor. Now, unlike a clamp that has like a jaw up top that clamps around the cables, those use a Hall effect sensor, which is a magnetic type sensor to measure the current going through. This is a different technology. This is based on a Nikola Tesla invention. It's called a current transformer, and we chose this technology instead of the clamp type because when you're trying to measure AC signals, if you want to be able to calculate power, you need to know when the voltage and when the current is happening, not just that it happened. So we're going to get more into that in the DeMoore Engineering University video series. In video 6 and 7 we'll learn all about that stuff, and why, if you were going to use clamps to measure, like all the things you would need to know. This tool does those types of things, as well as measure impedance and power factor and all kinds of neat stuff we're going to learn about. But let's I'm going to turn it on and we'll just start going through the modes. So turn it on. First thing we see, the little startup screen here. That checks the internal battery. Battery's good. And it's in the DC voltmeter mode. So right now it's a DC voltmeter. I can connect these probes to any DC voltage source. I can, let's see, I'll ground the black one here on my amp ground and put this on my distribution block. And there we see we got 12 So there you go. It's just a voltmeter. You can use it for whenever you need to measure a DC voltage. And I know some guys that have DMMs, like this is usually the mode they use. So we threw it in here and you can measure DC voltage. Now if I was to put these probes backwards on here like this, it still measures 0. A typical DMM would say minus 12 volts. Well, there is no minus DC voltage in an automobile. The battery ground is 0 volts or ground, and anything other than that is going to be positive voltage. So if you hook your meter up, your DMM, and it says minus voltage in a car, then you have your probes backwards. Instead of that, this just says 0, and then you know your probes are backwards the same way. Alright, that covers DC mode. We can go to the next mode here. We see we have a DC min-max. This records super fast. Will record the maximum and the minimum DC voltage that it saw. This is useful for looking what happens to battery voltage when you start the engine. Maybe to detect a bad battery, you can see what happens to battery voltage while you're bumping your system, see what the battery's dropping down to. It's much faster than other DMMs. So when the bass hits, you can really see what the battery's actually dropping down to. It works so well that I can put it across, what we're going to do, I'm going to put it across my positive battery cable from my amp to my battery. And I'm going to start up the car, or I'm going to start up the system, and just do a burp, and we'll see if we can measure the voltage drop on that line. So what we would do is the positive, or the red probe, always goes where the highest voltage is. So the highest voltage is at my battery positive terminal. So I'm going to connect this there. I've installed this jumper down to my battery positive terminal just because the meter leads won't reach. There's no current going through this wire whatsoever. This is just a sensor, a voltage sensor. So if the battery's in the trunk or under the hood, or it's 30 feet away from where you can get to, it's no big deal. Use a piece of speaker wire, any kind of wire. There's, like I said, there's no current going in. It's going to be just as accurate as if you were on top of the battery. So putting my positive probe there, and the negative probe goes to my amplifier positive battery terminal. So that way we're just across the positive on both sides. So the meter's all zeros right now. There's no voltage drop in that positive cable between my amp and the battery because there's no current flowing. So let me do a little burp and we'll see how much voltage I lose in the positive run to my amp. we go. Just on that piece of wire, I'm losing 0.7 of a volt. We could do the same thing on the ground side if we wanted to. See how much I'm losing on the ground through the chassis and whatever. So to do that, we would stick the black lead on the battery negative, because that is the lowest voltage. The black lead always goes on the lowest, and the battery negative is always 0. The amp ground is going to be higher voltage than that ground. I'm going to stick this into the ground at the amp. We'll reset the min-max meter. A lot of meters are really complicated to do this actually. You got to like switch it through a bunch of modes. This one you just hold this down until it gets back to the DC min-max mode, and it's reset. And so now our meter is across the negative. This is going to go, through the chassis of the car, through my negative cable and everything. Let's see what we lose on this side. What did we get? 0.6 of a volt. So I'm losing 0.7 on the positive side and 0.6 on the ground side, or a total of 1.3 volts. So that's handy to know. I could do some upgrades from here, figure out, some changes. But you can, that's one of the things you can use it for. Like I said, I could start the car. We could see what the minimum was when it started and what the maximum is when the alternator starts charging. We'll leave the negative on the battery negative, and I'll put the positive at my distribution block positive. Right there. And then we're going to reset the meter. Alright, and we start the car. And we're going to see a big drop in voltage when the starter activates. And it should raise as the alternator starts charging it. The maximum should keep going up. There we go. So we can see that I dropped to 8.9 when the starter engaged. This meter is so fast that that's not really a bad reading. This is a huge battery and it's pretty charged up. It's just when the starter first engages, there may be 1,000 amps that happen for a millisecond, and the meter reads that, and it reads that voltage drop. So once we all have these tools and we use them a lot, and we know how they react, we'll know when a battery's bad and when it's good. So that kind of covers the DC min-max mode, shows us some fun things you can do with it. I'm sure there's many other things you can do. You could find drops on the wire from your alternator, your battery, or who knows. I'm sure you'll find more uses for it. So let's go ahead and go to the next mode. Next mode on here is AC volts and current. So now it's an AC voltmeter and an AC current meter. If I take these probes, well, let me point this out. Notice the screen is blank right now. When it doesn't see any AC voltage, the screen is just going to be blank, because in order to properly measure true RMS, which is what this does, you actually have to count the sine wave and know when to start reading and when to stop. So right now there's nothing, there's no sine wave, so it's not doing anything. As soon as I put some signal, we'll see. So I've just connected it to my subwoofer box, and I'm just going to play some tone real quick, and we can see the AC voltage. True RMS AC voltmeter. So you can see it's reading the AC voltage output from my amplifier. It does have a clipping detector in it. If I turn it up high enough for it to clip, and it'll sense the clipping, you'll see this happen. That indicates that it was clipping at that voltage. Now, the current is reading 0 because we have no we're not making any current measurements. We have to run one of the speaker wires through the current transformer. Just like if you had a clamp and you had to clamp it around one of the wires. So it's an AC current, which means there is no positive and negative. It doesn't matter which wire we grab or which way we run it through that hole. I'm just going to grab this this one here from my subwoofer amp. Just kind of pull the boot to the side. The boot makes a real nice plug on the back of this hole to keep dust out. Okay, so now the voltage probes are hooked up to the positive and negative speaker output, and the speaker wire from the subwoofer amp to the subwoofers is going through the current transformer. So now if I go back to this AC volts and current screen, we'll see the voltage and the current. At the same damn time. What's beautiful about that, when you have one meter reading both of those things at the same time, you can divide those numbers and you can find the impedance. You can multiply those numbers and you can get power. But remember, in the information about clamping videos and in the DeMoore Engineering video 6 and 7 that are coming out, if you take a voltmeter and you take a clamp meter and you read those numbers and multiply them together, what you're reading is VA, or volts times amps. It's not watts, because for watts to happen, the volts and amps have to be happening at the exact same time. The amount of time difference that they're happening is the power factor. So on this next screen, the next mode, it's going to give us VA on the top line, or volts times amps, RMS volts times RMS amps. The bottom line is going to tell us the power factor. So if I burp it right now and it says 1000 VA and it says 80% power factor, that means that, yeah, if you had clamps right now and you did the math, you'd see 1000, but the power factor is 80%, which means only 80% of that power is actually going to the subwoofers. This is something that none of the clamping things do. None of those methods do that kind of thing. The only kind of meter that does this is a true power meter, which is what this is, and there's only a few on the market. They're about $3,000. So this one is got an audio twist to it, and it measures clipping at the same time. So it gives us a lot of power to do a lot of different things with it. But let me show you what this mode looks like. So what you saw there was 60 VA, or 60 volt amps, and a power factor of 80-something%. So I'm just going to go ahead and do a full-on, see how much I can get out of it, kind of a burst dyno thing here. Here we go. So I saw like 1600 and about 90% power factor. Now, it's not an amp dyno. An amp dyno, the amp dyno, will measure this amplifier here, this Rockford 2500 BD that we're using here, and an amp dyno will tell you the maximum power that this amp can do. The amp dyno extracts, it puts the amp under a heavy load, a purely resistive load, where the power factor, that percentage number we're seeing on the meter, is 100% always on the amp dyno. So the amp dyno can do that at any frequency. It can measure bursts like that. It's always 100% power factor, and it shows you what your amp is capable of. And if I put this amp on the amp dyno at 2 ohms, because I'm running a 2 ohm load in here, it might say 2000 watts, that this amp is capable of doing 2000 watts. Well, in my car, it's going to be different, because the impedance of this box is going to be maybe, 3 ohms at one frequency and 2 ohms at another frequency. And what we're going to see in this next section here is if I open a door, or open a window, or open the hatch, the impedance changes, the box tuning changes. The thing that people call box rise is just the impedance of the subwoofer reacting with the box and ported box have different impedance curves of a sealed box, and the same thing if this hatch is open, it's going to change the frequency of this ported box. If I open the sunroof, it's going to change it. If the weather changes outside, the barometric pressure drops, it gets colder out, all those things are going to change the impedance of the box or the box rise. So this is a good tool to know exactly what's going on with your system. If I try a different frequency on that last one, we're going to get a different number. I'm going to go up in frequency. I'm going to do 45 hertz. Now, a volt, I have no EQ in the system, so it's going to be the same voltage output at any frequency, but the power won't be the same because the impedance is changing, and we're looking at volts times amps. So here's 45 hertz. $1609, 89% power factor. It's not bad. Go 40 hertz. See, my power factor there was only 84%. There's probably another frequency in here where it's worse than that. Let me try 38 hertz. 86% there. But what you'll see is that can go all the way down to maybe 75%, and maybe a competitor, an SPL competitor, the frequency that they're playing in their car that works for them, they may be at a power factor of 75% when they play their beat at that frequency. So that means that they're only getting 75% of the actual capable power of the amplifier due to the way the box is tuned, the way it's sitting, the way the hatch is vibrating. Who knows? That's all stuff that this tool will let people find out. So anyways, there's VA mode with power factor. Go to the next mode here, and we're going to see AC frequency and impedance. So this is a cool mode. You can find the impedance of your sub at any frequency in your car. I know my box here is tuned to 28 hertz, but in this car with the door shut and the hatch shut, it's not. It's tuned at like 23 hertz. If I open the sunroof, it goes to 27 hertz. If I open the passenger door, it's 25 hertz. If I open the hatch, I don't know. It goes all over the place. No matter, or everything you change affects it, and you can see that all in this mode. Just like the IMSG, you could sweep it in the car and find all these different impedances, and you could do those things with an IMSG. You could open the sunroof and it would change, and this and that. It's the same tool, but this uses your amplifier power. So maybe you want to do that test at 1,000 watts and not at the low power of the IMSG, because the difference is that at 1,000 watts, maybe the hatch starts rattling at 42 hertz. Well, now my impedance at 42 hertz is going to be different than if the hatch wasn't rattling. It actually changes the impedance of the box at that frequency because the air load on the woofers changes. So let's take a look at this mode closer and see what we get here. So in this mode, we're going to be able to look at the frequency that's being played and the impedance in real time together. Just like the IMSG, you could use this mode to find the tuning frequency of a box, but you can do it at higher powers because you can use your own amplifier. It doesn't matter if there's EQ or anything, so it's reading the actual volt and the amp and doing the calculation. You'll see crazy things happen. I can run it at a certain frequency and see 4 ohms, and then open my window and it'll change the impedance. So for an installer, they want to make sure someone never goes below 2 ohms because of the amp they're using. They could run this, run all the frequencies, try windows down, windows up, sunroof open, whatever, change the tuning of the box. Same thing with competitors. If they have too much impedance at the frequency that is the loudest in their car, they can find ways to lower the impedance using this mode, and by changing the tuning a little here or there. Maybe they think it needs to be tuned at 35 hertz because they play 42 hertz and that's what they want to do, but they would find out if they, at 5,000 watts, if they tune it to 38 instead, the impedance is going to be lower at 42 or whatever like that. So there's a lot of experimenting that somebody could do with this mode here and find out some neat stuff. So let me just turn it on and sweep it around a little bit. You can see it reading the impedance in real time, and it doesn't really matter what my volume level is. But I really think that if somebody used this mode and they did a sweep when their car was sealed up and then they rolled their window down and did a sweep, they could see why it sounds different when the window's down, because you would see the impedance curve change a lot. Here, just for fun, I'm going to play 40, let's say 48 hertz, just for fun, and then I'm going to shut the driver's door and the passenger door, and let's just see if it changes. So with just the passenger rear door shut, the impedance went up about 3 or 4 tenths, and then when I shut the driver's door it went back to where it was. So you can see a lot of interesting things happening in there. I don't know what else I can say about that mode, probably a lot, but for now let's just go on to the next mode. So the next mode we have is True Power mode. Now True Power is different than the VA mode. Like I said, the VA is like what clamps would read. It's volts times amps. It doesn't care when they're happening. It doesn't account for the phase angle. It doesn't look for clipping. It doesn't do any of those things. That mode is only in the meter for someone to figure out what their power factor is and why it's there. It's not to be interpreted as watts. That's why it doesn't say watts. It says VA. That's what it is. The real power meters, not that this one isn't real, this is very real. The ones you can buy right now on the market already, like the $3,000 Fluke, that's what it'll tell you. It'll tell you your VA, it'll tell you your power factor, and it'll tell you your true power. And that's exactly what this tool does. And it'll do it in the audio frequencies from, you know, as low as 10 to 15 hertz up to around 1K or so. So I've got it back in this mode, and I actually want to do something else first though. I'm going to go back to the VA mode, VA and power factor, and I'm going to play like 50 hertz, and I'm going to burp it, and we're going to see what the VA and what the power factor is, and then we're going to put it in the true power mode where it reads phase angle and clipping and all that stuff, and we can see what the difference is. And again, with this stuff, I could read the power and I could roll my window down. I could do it again. It's going to be different because the impedance is going to change, which is going to change the current. It could change the phase angle. You never know. A lot of fun experimenting to be done with this tool. Find a frequency that's got a really bad power factor. So right there I'm at 39.7 hertz. The power factor is only 81%. So only 81% of the power is actually real power that's going to the subwoofer. So here I'm going to go ahead and do a burst here, or a burp sorta, with my volume knob. So I saw about 1580 VA and like 85% power factor. And then we can go to an actual power measurement, true power. See the difference? And it holds the highest number that it saw before clipping, kind of like an uncertified mode, but again, it's not compared to the amp dyno. This is reactive loads in the car. It has nothing to do with how much power the amp can put out. This number, I mean, there's my BD 2500 full on to clipping. It did 1162 watts. That has to do with my box, the tuning frequency of the box, which windows are open, you know, what the air temperature is outside. All those types of things affect this number. So right now at 39 hertz, that's the power I have. And you know, like I said, a lot of things can change it. It holds that peak number, so if I want to erase it, I would just change modes back. But instead of erasing it right now, I'm just going to shut the passenger door just to see, because if it does more power, it'll update it with more power. So I just want to see, maybe I get more power with the passenger door shut. I did not, because it didn't change. So that means it was exactly the same or it went down. So let's go ahead and reset it and find out. Again, just push and hold till you get back to the mode again. It's the easiest way to do it. I hate menus. I hate having to go through menus. Alright, door shut. Here we go. See, so with the door shut, it only does 1112 watts, and that's what we're seeing. The dynamics of the air pressure in the car changing. It's raising the impedance or changing the power factor at that frequency when that door is shut. I'm going to open the sunroof just for fun. I feel like every car I've had always has some mode where it's louder, you know? It's like, oh, in this car I got to roll the passenger window down. That's when it bumps. I don't know. I feel like this Jeep with the sunroof open, it loves it. So. But I don't know if this is the frequency it does it, but let's just see. Nope, 1130 with the sunroof open. Alright, passenger window down. See if I get any more. Here we go. Nope. Alright, let me try a different frequency. Maybe I can get more power if I play 35 hertz. Just a little bit more. Let me try 30 hertz. See, just by changing frequency down at 30 hertz, I get another 200 watts because that's how the impedance curve of this box works and how the power factor of this box works. So that's a quick, try not to go too in depth. Like I said, the Demore Engineering videos 6 and 7 are going to get into all the power measurement stuff a lot, but this thing does DC, AC, does AC current, it reads clipping, it reads VA, it reads power factor, it reads impedance, it reads frequency, and it reads true power, which is what we just saw. So hope you love it. Something else I just want to throw on the end of this video, maybe it's maybe an installer's working on a car and you know, the car comes back and the customer says, hey, I play this song and at this one part it cuts out. You know, maybe you would like to be able to hook this meter up to their sub and play the song and watch the impedance in real time and watch the frequency and see what happens as the song's playing. Does the impedance ever drop below a safe level? Or maybe you're just like, hey, that new song by so-and-so, I like it. It's got that low bass note in it. I wonder what frequency that is. I'll put this meter on and find out. So this is just a little, like I said, there's lots of things you can do with this and a lot of things. This is just like one little cool little hack you can do with it. So check this out.
Everybody will be dancing and we'll be right. Everybody will be dancing and be right. Everybody will be dancing and we'll be right. Everybody will be dancing tonight. Everybody will be dancing and we'll be right. Everybody will be dancing and be right. Everybody will be dancing and we'll be right. Everybody will be dancing tonight. Right. Everybody will be dancing and we'll be right. Everybody will be dancing and be right.
There you go. It's just a cool little demo real quick of that.